Hello guys, and welcome to my geometry final project for geometry day 3 on June 6, 2020. Now, for our first problem, we are given ABCD, a parallelogram. Now, we are asked to find the perimeter of ABCD. Now, first we must understand that AB is equal to DC due to the theorem of parallelograms, which states that opposite sides are congruent, right? So after we know this, or understand this, we know that BC is equal to AD and that 2x plus 6 is equal to x plus 8 because AB is equal to DC. Now first we set up an equation, 2x plus 6 equal x plus 8, because remember AB is equal to DC. And we solve this equation by isolating x. So the first step is we minus x on the right side to the left side. And then after that we have x plus 6 equal 8. Now all we have to do is minus 6 from the left side and minus it on the right side as well. And I get x equal 2. Now remember that AB is equal to 2x plus 6 and that DC is equal to x plus 8. Now in order just to solve their measurements, we simply have to plug in what we got for x, which is 2. Now after we plug it in, we get 2 times 2 plus 6. Once we add up both those numbers, right? 2 times 2, 4, plus 6, 10. 2 plus 8 equal 10. Then we know that 10 is equal to AB, and that 10 is equal to DC. Now, since our earlier words said that BC was equal to AD, we just have to set that in motion. So we know that BC is equal to 8, and that just means that AD is also equal to 8, since they're equal. So after that, we simply need to add up all the sides, right? 8 plus 8 plus 10 plus 10, right? Which gives us 20 plus 16, which is 36. The perimeter is 36. Now the next problem is problem 54. Now DE is said to have endpoints E 4, negative 2, and D is said to have coordinates such that the x coordinate is 3 more than the y coordinate. Now before we start solving this problem, we first must set up the D coordinate. Now since the x is supposed to be 3 bigger than y, it's the same as 3 plus y, since it's supposed to be 3 more than y, right? So then we can write that as 3 plus y, y. So that could be our D coordinate in terms of variables. Now, then we must use the distance formula and use D as a substitute. Then we get 15 is equal to the square root, parentheses 4 minus y plus 3, parentheses squared, plus parentheses negative 2 minus y, parentheses squared to 2. Pretty long, right? The simple way to do this is to simply simplify, right? What's inside the parentheses? So then we get y minus 7 squared to 2. And then negative 2 minus y, parentheses, squared to 2. After that, we get that huge equation after that line, and then we just have to combine like terms. After that, we get y squared to 2, no, just y squared, plus 19y, plus 53, square root of that equals 15. Now, the best way to do this is to simply get rid of that square root by squaring both sides. And that leaves us with y squared plus 19y plus 53 is equal to 225. Now we just have to minus 225 in order to have it set to 0. And then we get y squared plus 19y minus 172 is equal to 0. Since we cannot factor this, we just have to solve it with the quadratic formula. Now a is equal to 1, b is equal to 19, and c is equal to negative 172 because 1 is in front of y squared, 19 is in front of y. The negative 172 is the constant. After that, we do that. We get negative 19 plus or minus negative 361 minus parentheses negative 688 parentheses over 2. Now after we simplify all that, we get y is either equal to negative 19 plus or minus square root of 1049 parentheses divided by 2, which gives us two answers, right? 6.694 or 25.694, which leaves us with the two answers that D is either 20.082, 6.694, or D 77.082, 25.694. And that concludes problem 54. Now, moving on from that irksome number 54, we're going to go with an easier problem. Problem 94. Now, for problem 94, it is stated to be a right triangle. You could either find this out by just pointing out the right angle that is drawn in. Or you could just simply say it was stated to be so, right? Now that we know that, we can just use the Pythagorean theorem, which states that a squared plus b squared is equal to c squared. Now all we have to do is plug in our own terms, right, for each variable. So then we have x squared plus x parentheses x plus 7 squared equal x plus 8 parentheses squared. We then get that huge equation, and all we have to do is minus the left side by the right side. And then after we do that, right, we get x squared minus 2x minus 15 is equal to 0. Now just factor this and we get x plus 3 parentheses x minus 5. Take the root of this, right, which is 5. The answer cannot be negative, as measurements cannot be negative. There's no such thing as negative inches or negative centimeters. So with that in mind, we just simply have to plug back x in the original equations for each side. So side b is equal to x, which is equal to 5, since we made it clear that x was 5 on the right here. And then all we have to do is do the same thing for the side a. Side a is equal to x plus 7, which is equal to 5 plus 7, which is equal to 12. Then side c, x plus 8 equal, we plug 5 in, 5 plus 8 equal 13. Now our sides are 5, 12, and 13. And that is problem 94. Now for number 103. First, for 103a, we must first remember that parallel means two lines that never touch, right, that have a set amount of distance, right, but we can use a visual example in our own heads to help us solve this cross section. Now think of a parallelogram. When you see those two lines that are opposite from each other, what do you think? Parallel, right? They're always horizontally, never always going in the same direction, right? But you see, like they never go, it never like starts, the line never starts like curving to the left, or the line on the left never starts curving to the right, so that they never intersect. Now once you think of that, you're like, oh, that's simple. It's just horizontally cut, right? So after we horizontally cut it, we just simply get a circle, right? As right shown right here, right? That's a circle. Now for B, right? Cut perpendicular, right? Perpendicular is like two lines, right? Like a Cartesian plane, right? Two lines. Now we see, does it line up? It has to line up, right? Now think of it, like, think of this example D, right? This is lining up, right? 3D perpendicular plane, right? 3D. It's lining up vertically. So you have to vertically cut this, right? In order for it to be perpendicular. And then we get simply triangle. As we vertically cut it, we think that we go back to the original point that a cone is simply a triangle rotated around a fixed point. That being the tip point, right? Or basically any other point, really. And then it creates a circle on the bottom, and that's a cone. Well, perpendicular is just kind of getting that original shape out of there, which is a triangle, right? And then for number C, or just we can call it 103C. It's the same principle as earlier. Cut parallel, remember the parallelogram example, just cut horizontal. What do we get? We get a circle, right? That's a circle. Then we go to D. A cylinder is cut perpendicular to its base. Remember how our rotating example helped us with B just a few seconds ago? Now just applying that, we remember that, oh, I rotate a rectangle in a like 360 degrees, right? There's going to be two circles on the top and bottom, right? That's a cylinder, right? Perpendicular is just cutting that vertically, right? Another way to do that is just say cut it vertically, or you can think of these examples, right? And since you cut it vertically, it's going to be a rectangle as shown, right? And vertically, right, is in essence the same perpendicular, right? And this at least because it lines up perpendicular in 3D and perhaps 2D as well, right? You see it goes down right here, and it's perpendicular. It slices it, right, like vertically, right? It has to be a vertical line, otherwise it won't cut the horizontal line like it's perpendicular, right? And that concludes our geometry final. Thank you for watching, Mr. Martin. I hope it was worth the watch, and I hope to see you in Xavier next year. Cheers!